Hi all, I welcome you all for my channel Electrical Engineering Simplified. In the previous video, I have explained about how to find the transfer function of mechanical translational system. I have given the link in the description box. In this video, I am going to explain how to remember force voltage analogy and force current analogy for both mechanical translational and rotational system in an easy way, and explain this using one problem. For force voltage analogy of the mechanical translational and rotational system, take series RLC circuit. Force voltage analogy for the mechanical translational and rotational system have to take the series RLC circuit, and mechanical rotational system take series RLC circuit. First of all, I am going to draw the series RLC circuit. R is the resistance and L is the inductance, C is the capacitor that is connected across the voltage source V. If the voltage is connected across these components, the current is flowing through a circuit, that is I. How to write the equation for voltage? V is equal to R into I plus L into di by dt plus 1 by C into integral I dt. Next substitute, I is equal to dq by dt. What is Q? Q is charge, T is time. Current is charge per time. Next I am going to apply, instead of I, dq by dt. P is equal to R into dq by dt plus L into d by dt of dq by dt plus 1 by C into, from this equation, I is equal to dq by dt. What is dq? dq equal to I into dt. Take integration on both sides of the equation. Q is equal to I into, so Q is equal to integral I dt. Instead of integral I dt, I am going to substitute Q. P is equal to L into d square Q divided by dt square plus R into dq by dt plus 1 by C into Q. This is force voltage analogy. Next, consider the parallel RLC circuit for force current analogy. For force current analogy, take parallel RLC circuit. I am going to draw the parallel RLC circuit. Current I. Parallel RLC consists of resistance R, then inductance L, then capacitance C. This is the parallel RLC circuit. What is the voltage across it? That is V. Now I am going to find out the equation of current. Here the voltage is V. I is equal to V by R plus 1 by L into integral V dt plus C into dV by dt. Next I am going to substitute V is equal to d phi by dt. Phi is the flux. This is Faraday's law. So I am going to substitute d pi by dt in the above equation. So what is the new equation? I is equal to, instead of v, I am going to substitute d pi by dt. 1 by r into d pi by dt plus 1 by L. What is integral v dt? That is equal to pi plus c into v is equal to d pi by dt, no? C into d square pi by dt square. So first I have to write the higher order. C into d square pi divided by dt square plus 1 by r into d pi by dt plus pi by L. This is the equation for current. Now we got the equation for voltage from series RLC circuit and the equation for current from the parallel RLC circuit. So voltage that is used for force voltage analogy and current force current analogy. Now I am going to explain this using a table. First write voltage equation V, that is L into d square q by dt square plus r into dq by dt plus q by c. Okay, next I am going to write I. For force current analogy, I is equal to c into d square pi by dt square plus 1 by r into d pi by dt plus pi divided by L. Next I am going to compare this equation with Gauss equation for mechanical translational system. In the mechanical translational system, we are having three different components as mass, dashpot and spring. And mechanical rotational system consists of moment of inertia, dashpot and torsional spring. So first I am going to write the force equation for mechanical translational system. F is equal to m into d square x by dt square plus b into dx by dt plus k into x. Here m is the mass, b is the dashpot element, that is for friction, k is the spring element mainly for displacement. Similar manner, I am going to write the torque equation for mechanical rotational system. The equation is T is equal to J into d square theta by dt square plus b into d theta by dt plus k into theta. What is T? T is the torque. And what is J? J is the moment of inertia. Theta is the angular displacement. And B is the dashpot. K is the torsional spring. Now what I have to do, I am going to compare voltage equation with force balance equation for mechanical translational system as well as mechanical rotational system. Next I am going to compare the I with mechanical translational and mechanical rotational system. So that I am going to draw a tablet column that gives a clear idea about the force voltage analogy as well as force current analogy. So first column write mechanical translational system, and second column write mechanical rotational system, and third column write force voltage analogy. Next, force current analogy. Okay, first, for the mechanical translation system, put F. The same in the mechanical rotational system is T. And here linear displacement X and angular displacement theta. Next, first element is mass. Here that is moment of inertia. B is a dashpot. Here also the element dashpot. And third element K is a spring, and here torsional spring. Next write the force voltage analogy. M is equivalent to L. J is equivalent to L. Then B is equivalent to R. B is the friction that restricts the motion of the body. Here R is the resistance that resists the flow of current. Okay, in this way you have to remember B and R. And next, torsional spring is equal to 1 by C. So L or 1 by C. How to write in the force current analogy? From the force voltage analogy, we can easily write using force current analogy. L is equivalent to C. Correct? And R is 1 by R here. And 1 by C here 1 by L. Just you have to write the same inversion, but here C means you have to write L. And then for the mechanical translation system and rotational system, force voltage analogy, force and torque is equal to voltage. And here force current analogy, force and torque equal to current. And next, the displacement x and theta, that is equal to Q. This is the force voltage analogy. Here that is equal to pi. Flux is in the force current analogy. So this is the way to remember this tablet column in an easy way. Next I am going to explain how to draw the analogous system, analogous electric circuit using force voltage and force current analogy. Here the given system is a mechanical translational system. So first of all, what I have to do, I am going to write the equation for voltage and current. For a force voltage analogy, I am going to write the voltage equation. V is equal to L into d square q by dt square plus R into dq by dt plus 1 by C into Q. In the similar manner, I is equal to C into d square pi by dt square plus 1 by R into d pi by dt plus 1 by L into pi. First of all, I am going to explain how to draw the electrical analogous using force voltage analogy. For the force voltage analogy, first of all we have to consider how many displacements are there. x1 and x2. There are two displacements x1 and x2 corresponding to two loops. Okay, force analogy means that is the mesh equation, right? The mesh equation. Always, another one condition is there. Always start from the mass which consists of force element. Okay, here the mass which consists of force element is m2. So you have to start from the mass m2. Okay, here m for force voltage analogy, m is equal to L and the force is equal to B. K equal to 1 by C. B equal to R. So first of all, I am going to draw the first loop. The first loop consists of mass M2, that is inductance L, force, that is voltage source V, B1, that is resistance R1, B3, resistance R2, K2 inverse of capacitance. I am going to draw the circuit. Instead of force, it is voltage, and then L2, that is M2, then B1 and K2 is common for both the measures. So how to represent B1? That is R1, K2 is 1 by C2. Then again one resistance, that is B3 is there, that is R3. The first loop is completed. And second loop consists of first the inductance, that is M1, and these two are common, already have drawn, and K1 instead of K1 have to use 1 by C1, and another one B2, friction is there, friction is relevant to the resistance in force voltage analogy, put R2. So two loops are formed. Okay, these are about force voltage analogy. And next, I am going to explain the force current analogy. In a force current analogy, x1 and x2 means number of nodes. Okay, two displacement relevant to two nodes. Have to mark the nodes first. And this node represents voltage V1 and this is voltage V2. In between two nodes, we are having two components. Okay, how to draw this? First draw the dashpot B1. In a force current analogy, dashpot B1 that is equal to 1 by R1. And what about K2? K2 is equal to 1 by L. Draw the inductance and put 1 by L2. Okay, then M1, 1 by L1 is connected. Again, 1 by C1 is connected. M1 is connected. M1 means C1. And here have to consider B2, B3 equal to 0. There is no frictional element. And then which one is connected in parallel here? That is K1. K1 means 1 by L1. And next, in the nodal point B2, which one is connected? This is the nodal point B2. In the nodal point B2, C2 is connected. C2 represents the mass. and another one element that is connected, that is force. Force is equal to current, that is I. This is the force-current analogy. This is the way to draw the force-voltage analogy and force-current analogy from the mechanical translational system. If you use the mechanical rotation system also, the similar procedure is used to find out the analogous system, that is electrical analogous system. Thank you. Have a nice day.